Okay, welcome back. So this is part 3. Okay, we start with the third question. An arithmetic progression has a first term of 7 and a common difference of 0.4. Find the least number of terms so that the sum of the progression is greater than 300. So when we read out the question, we identify A as A as 7, the first term, and the difference is 0.4. B. So the sequence be like 7, and then 7.4, 7.8, 8.2, 8.6, 9, 9.4, and so on. Okay? So, you also have to take note that the sum of the progression is greater than 300. Okay? S sub n is referring to the sum of the progression. That means 7 plus 7.4 plus 7.8 plus 8.2 plus 8.6 plus and so on. Okay, the value of that summation is greater than 300. So we have to find the least number of terms for that. Jelas ya? So kita akan pergi dulu macam mana, apakah sum of progression for this one. Okay, so this is the formula for the sum of an arithmetic series. Okay, so sum of arithmetic series, sum S sub n equal to n over 2 in bracket 2a plus n minus 1 times b. Okay, so you're going to apply this. Okay, so we apply the formula of sum of arithmetic progression. Okay, we get this part. Okay, just apply the formula here, where A is 7 and D is 0.4, and let's simplify the inequality as being shown here. You may pause the video if you need to. Alright. Okay, when you solve the inequality of this quadratic expression on the left and 0 on the right, right? So you find that the quadratic expression is greater than 0. So when you solve the inequality, you will get n has to be greater than 25.29. Okay, in order for the sum of progression to be greater than 300. Okay, just take note that n is a discrete data, where n is countable. Okay, 1, 2, 3, 4, 5, and there's no such thing as 1.5, 1.3, no, because this is a discrete data. Okay, so since n has to be greater than 25.29, so n is a whole number, so n has to be 26. Okay, the least number for the sum of progression to be greater than 300. Settle question 3. Okay, this is question 4. Using the substitution y equal to 2 to the power of x, or otherwise solve 2 to the power of 2x plus 1 minus 2 to the power of x plus 1 minus 2 to the power of x plus 1 to 0. Okay guys, okay, I'm going to show you how to solve this one. So we're going to use this one, y equal to the power of x. So apa yang kita boleh buat di sini? Okay, sekejap ya. Then we can actually change this 2 to the power of 2x plus 1, okay, by using the concept of indices. This is equivalent to 2 to the power of 2x times 2 to the power of 1. Okay, and then this 2 to the power of 2x can be written as this 2 to the power of x in bracket to the power of 2. Okay, the reason I'm writing it this way, so that we can get we can write this 2 to the power of x in terms of y. Okay, so we will get actually over here y square times 2. Okay, y square times 2. Okay, which is equivalent to 2y square. Okay, equivalent to 2y square. Okay, I hope you understand, right? So we're going to do something like this, okay? Something similar like this, to the rest part of the expressions, eh? To the rest part of the expression on the left, okay? Okay, then we get something like this, right? Okay, good. We have rewrite. I have rewrite this one, okay, in terms of y. So we get 2y square minus 2y minus y plus 1 equal to 0. Okay, if you can't get what I'm saying here, okay, you may take a pause of this video and try to figure it out. Any questions, you may directly WhatsApp me. Okay, so we can simplify this part, negative 2y minus y, so we get negative 3y. Okay, just simplify. And then we try, and then the next step is we just have to solve this quadratic equation. Okay, simplify the quadratic expression, we will get get 2y minus 1 and also y minus 1. Okay, equal to 0. So you solve this one, you get 2y minus 1 equal to 0, and you get y minus 1 equal to 0. Y minus 1 equal to 0. Okay, then you solve this one, you get y equal to half 1 over 2 and y equal to 1. Just bear in mind that we want to find the value of x. So do not stop until this point. Okay, do not stop up to this point. No, make sure you continue until you get the value of x. So y is actually equivalent to 2 the power of x. Okay, bear that in mind. So we have this one, 2 to the power of x equal to half and 2 to the power of x equal to 1. What is this? Okay, equal to 1. Like this, yeah. Alright. So there are many ways of doing this. You can use log. Okay. You can also use the concept of indices. Okay. So I'm going to solve this part first. 2 to the power of x equal to 1 over 2. Okay. So 2 to the power of x is actually equivalent, sorry, 1 over 2 over here is actually equivalent to 2 to the power of negative 1. Okay. Alright, and then the other part is, okay, over here. Okay, 2 to the power of x equal to 1. 1 is actually equivalent to 2 to the power of 0. Okay, so over here we can solve for x. Okay, if 2 to the power of x equal to 2 to the power of negative 1, okay, the base on the left equal to the base on the right. That means the power on the left must be equal to the power on the right. So x must be equal to -1. Okay, by using the same manner, you can find, in the same manner, you can solve for the other part. So you get x equal to 0. Done.